Okay, welcome to week 12. This week we're just going to carry on learning a bit more about how to write functions. Specifically, we're going to look at catching errors and writing slightly more complicated functions, in particular functions within other functions. Okay, so last week we had this function called multiply it, which took two numbers, x and y, and returned the product of those two numbers. So I said that one of the drawbacks of this function as it stands is that if I say do multiply it hello, we get this error. Now for this small function this isn't so much of a problem, we know why the error is being caused, but as functions get bigger and more complicated we need to make sure that we catch any errors as soon as possible. So one way of doing that is that we make sure that our input makes sense. So here the problem is that our input, we're supposed to have a number here, and this is not a number. So we can use if statements to try and catch problems with our input. So I'm going to use if is.numeric x. So that says, is x a number or not? I'm going to reverse it because we want something to happen if x is not a number. So remember the exclamation mark means not. So if not numeric x, then, so the next line controls what happens then stop. So we want the function to stop, and the argument to the stop function gives us some text that we can return when the function does actually stop. So let's put x needs to be a number. Okay, and now if I run this, you can see there it stopped, and rather than the error being in y times x, the error is actually in my function. So I've caught it before it's gone to this y times x, which makes little difference here, but if my function was bigger, it's a big benefit to catch that error as soon as possible. And just to check that the function still works when I supply an appropriate input there. It also still works, now here's one to watch for, it still works if I supply a vector. On page 3 of the workshop we've used a slightly different argument here, is.real. Now this is a slightly different one. This will fail on a vector. So is.real checks whether x is exactly one number. So that's fine if x is one number, like that. So just be aware that that's the behavior of is.real, whereas is.numeric is quite happy to accept a vector as long as all the contents of the vector are numbers. So use whichever one is appropriate to what you want to do there. Okay, obviously we could also have a similar if statement checking that the input y is also appropriate. So I'll leave that for you to add. Okay, now let's have a look at possibilities of a slightly more complex function. So I'm going to suppose that I want a function that does times tables. So I'm going to call my function times table, and it's going to take a single input z, which is going to be the times table that I want. So in other words, 1 times z is z, 2 times z is 2z, etc. So what I want this function to return in the simple case would just be, say if it was 2, just 2, 4, 6, 8, 10, etc. So the way I can do that is I can put in the function, we'll multiply it, all the numbers 1 to 10 for my times table. Let's put y to just be z. So there's my function. So now if I run this function times table, say 2, so I've got an error message there. That's because I forgot to put, as I was saying, real will not accept a vector. We need to put is.numeric instead if we're using it for this purpose. And there are the results for that, 2, 4, 6, 8, 10, 12, etc. Of course, at the moment the error is going to be caught somewhere else because of we haven't put error checking into the times table function. So we could also put a command like this into my times table function. So here if is.numeric z, stop, z needs to be a number, and that will mean that the error happens right at the beginning in my times table function. Now just for something a bit more advanced, let's just illustrate how we could tidy this function up a bit. Let's call this out, and I want my output now to come out in a nice format. I want it to come out like, I'll show you, sort of 1 times 3 is 3, 2 times 3 is 6, etc. So I'll show you how to make something like that happen. So I'm going to use a print command within a for loop going over all the different times tables. So I'm going to ask for print, and then I want to print a vector, and print automatically accepts a vector and prints all the elements of the vector consecutively. So here I want to print I multiplied by z. So I goes from 1 to 10, z is the fixed number that our times table is going to be of, equals, and the answer is the thing that I've just stored here in this vector called out. So for this particular instance, it's the ith entry in that vector. So I'm printing that. So now if I run this function, you'll see what I get. It's still a minor problem. We've got these quotes. Print also has something called quote equals false. In fact, you can just see it in the help file that I've got up in the right hand corner down there. So now I've put quote equals false. That should tidy it up nicely, and you can see that it's produced what we want. The format could of course be improved, but that's that's just quite nicely giving us the output we want. Of course, I could put any number in there that I want, and it will just produce that times table. Okay, so that's everything for week 12. Next week we'll be moving on to matrices, which you will notice aligns very closely with the work that you're doing in Math 103.